Okay, good morning. I think I'm on live. It says I'm on live. If you could hear me, I don't think anybody's on right now. I think I'm the only one that's on, which is good because I'm a little shy. Okay, so we're gonna go ahead and we're gonna get started. If you are listening, watching this after the live, good. That's why I'm doing this, so that it stays up on YouTube and you can watch it on your own time. If you're watching this live, let me get on the chat and if you want to write your questions in as streaming, I'm gonna Okay, good take a peek there. I think I'm on live. Actually, I don't think I'll be able to look at the chat uh because it's like there's like a delay with it. Um So, all right. So the way we're gonna do this, I'm gonna go through the Algebra 2 Regents, and I'm gonna try to do it in the most efficient way. My target audience here is not the high level student, but also not the low level student. I'm going for the student right in the middle. So if you're a high level student, you might get bored a little bit. So if you're watching this after the fact, maybe play me at double speed. Um, and if you're a mid-level student, like this is for you. I'm doing this for you. That's like most students in my classes. Um, and yeah, so I'm gonna try to do this in the most efficient way. I'm gonna take a break at some point. And because it's gonna be long, I'm gonna be here a while. All right, so let's go ahead and get started. So it's the Algebra 2 Regents. This is the June 2023. If you want to print it out or if you want to just do this on loose leaf as I'm working through this, I think it would help you to work through the problems with me. You should also have a calculator. I'm going to use the TI 84. And all right, let's do this thing. Okay, so let's go to page 2 here. Okay, so here is question 1. Population of Austin, Texas from 1850 to 2010 is summarized in a table below. Over which period of time was the average rate of change in population the greatest? So average rate of change is the slope formula. So we got 1850 to 1910. So let's recall the slope formula. Okay, so if you're looking for the average rate of change, I call it A rock. Right. So you could you could write it like this: f of b minus f of a. You could do this function notation stuff. Uh, or you could, if you prefer, right, it's just y2 minus y1 over x2 minus x1, right? It's that same formula. It's the same thing. So if we're doing 1850 to 1810, right? So that's 1850 to 1910, excuse me, right? So it's going to be, so here's your x1, x2, and then this is your y1 and your y2, right? So you could see it's something that you're going to have to do for each of the choices. But, it's a fairly simple question. Shouldn't be so hard. So let me grab my calculator because I think this is a good question to use a calculator for. And I'm just going to be going back and forth between the screens. So, okay, so here it is, my calculator. So I'm gonna go ahead and do the first choice. What was it? It was, first choice was 1850 to 1910, so that was 29, 860 minus 629. Okay, that's the numerator, and then the denominator is 1910 minus 1850. Right, then we divide 29, 231 over 60. Oops, I think I did that wrong. Let me do that again. 29, 231 over 60. So we get about 487 for that first one. That first choice. So the second choice, and it's gonna be this question is a little annoying because you have to do it for each of the choices because you're looking for the one that's the greatest. So then choice 2 was 790, 390. See if I could just knock this out in, so I don't have to do it numerator and then denominator, just do it all in one shot. So 79, 0390 minus that again. 290. Got the minus sign again. Just bear with me. 494, 290. Okay, that was the numerator for the second choice, and here's the denominator, 2010 to 1990. Okay, so for the second choice, you could see it's a greater average rate of change. You get 14,805. Okay, so now for the next choice, choice 3. Okay, we got 251. So these numbers is in the numerator, it's y2 minus y1. So they're coming from the y values. Okay, 251,808. And then we got minus 13, 9 over 1970 minus 1950. So we get 5,000, about 5,967. So we got to do the last one, right? Because you're looking to see which one's the greatest. So unfortunately for this question, you have to go through each of the choices. That's the nuisance to this one. So the next choice we got 251,808. 808 drums. 14575 over 1970 minus 18. Whoops. 1890. So you get 2,965. All right, so let me go back to the other screen and then just write these out for you, the calculations. Okay, so I think I could do that, right? And then go on the whiteboard, existing whiteboards. Sorry, kind of annoying. Okay, so all right, so to reiterate, what we did, right? A rock average rate of change is just y2, right? That slow formula minus y1 over x2 minus x1, right? And so the year, right? These are your x values. Okay, and then the population, those are your y values. That's just pretty standard, time, x values, and then whatever else, right? Those are your y values. Right, so I'm not gonna write out the whole calculations, right? That's just gonna take too long. I don't want to bore people that much, but I do want to write the results that I got. So for choice one, if you remember, we got about 487, right? About 487. I think there was like a decimal somewhere, but that's not that important for this problem. Second choice is 14,805. 805. The third choice we got was 5967. Sorry, was it 5967? Hold on, let me go back to the calculator. Yeah, it was 5967. 5967, and then the last choice was 2965. About 2965. So you could see, right, the correct answer is going to be choice two. Kind of an annoying question, but it's low-hanging fruit. If you know the slope formula, you just got to do the slope formula 4 times and then pick the one that's the greatest. All right. Let me just take a second to check the YouTube live. I just want to see if anybody's on. I'm new to this stuff. I guess to not that new, but fairly new. Just want to see if anybody was able to get on. It says 3 people are watching. Yay. We got 3 people watching. All right. I don't see any questions on the chat, so I'm going to continue. I'll check this later. Okay, so good. Happy to see we got some people. All right. Tell your friends about it. Spread the word. Let's keep it going. All right. Choice 2. Which expression is not equivalent to that thing? Right? Which expression is not equivalent? So, geez, Louise. All right, let's go for it. So, trying to figure out what's the fastest approach to this, or like the most efficient approach. I guess what we could just look at all the choices first, right? And so if we look at all the choices, you could try to pay attention to some things like right now, I'm looking at how this is a negative and this is a positive. And I see that here too, like a negative and a positive. I see here a negative and a positive. Like I see that commonality. So that's an interesting thing. And actually, I think I just saw the answer. Like I'm looking at choice 3, and I'm going to tell you why I'm looking at that. I see the 6 times 6. That's going to get you the 36. But that x to the 6th times x to the 6th is going to give you an x to the 12th. So that first term is going to be 36x to the 12th power for choice 3, right? That first term. And the middle terms are going to cancel out because of the plus and the minus. And then, so I'm going to say the answer is choice 2. And just by the way, I'll keep it real with you. I'm just doing this kind of on the fly. And so, I didn't like cheat ahead of time and do this test. I'm really just trying to put myself in the position of the student. and doing it that way. So yeah, so I found the answer right away. I was just able to see that x to the 6 times x to the 6, that first term is going to be x to the 12. If you wanted to look at all the other choices, you can. But I think I'm just going to move on for the sake of time if I find the answers. All right. Okay, number 3, what are the zeros? So when it says what are the zeros, that's just asking for x-intercepts. Okay, so I think the approach to this question would actually be to graph it. And it should be a simple graph because if you look at all the choices, you could kind of see the x-intercepts, right? Like you got -3, -2, 5 in a lot of the choices. So I think this is a question where you could graph it and then you could just see where with your eyes on the graphing calculator where the x-intercepts are. So that's going to be my approach for this, right? You could try factoring it, but I'm going to, like I said in the beginning, if you missed it, I'm going for like the mid-level student. I'm not trying to do like I'm trying to keep it as simple as possible in my approach. And I'm also looking for efficiency. And I'm also looking for ways to just say, okay, now I know this will definitely be the answer, right? So if you're just able to do it on the calculator, I think it's more precise, it's more accurate. You could make mistakes on the factoring. So I think the calculator approach is the best one here. All right, so having said all that, let's share my calculator. Okay, and then we're just gonna go to y equals, and we're going to erase everything that's here. You can see I've been doing math. And we're gonna type it in, x to the 4th, x to the 4th minus 9x squared. Geez, they give you these long functions. Sorry if I complain too much. Minus 9x squared plus 3x to the 3rd. Right, minus 27x. I also have horrible short-term memory, so I have to keep going back and looking at all the terms. What happens when you get old. Minus 10x squared plus 90. All right, make sure I type that in right. Plus 90. Yep, looks right. All right, let's say graph. Okay, so you could see 1, 2, 3, 4. You could see there's 4 x-intercepts. That means you have 4 zeros. So the answer can't be choice 1, it can't be choice 2. So you're down to choice 3 and 4. You could see also, here's the origin, so that's -1, -2, -3, -4. And you see -5 is in x-intercept, -5. You got -3, you got 2 and 3. Okay, so that wasn't so bad. Okay, let's bring it back to the whiteboard. So the answer is choice 4. All right, so just do that on the calculator. All right. Let's keep going. Okay, here we got number 4. What do we got here? If theta is an angle in standard position whose terminal side passes through the point -2, -3, what is the numerical value of the tan of theta? Okay, so I think what we're gonna do here is, the approach here is to just make a quick sketch of this angle. Okay, so I just made a a little coordinate plane, right? So you got X and Y, and so then you have the point -2, -3, right? So we got this point right here. And we're gonna sketch an angle. Okay, so theta is the reference angle, right? It's going to be the angle between the terminal side and the x-axis. Right, so keep in mind this point here, right? This was -2, -3. Okay, so that means this side here for this right triangle, right? This is 2 and this is 3. Okay, so now the tan of theta, remember SOHCAHTOA? SOHCAHTOA, right? So the tan of theta is equal to the opposite over the adjacent. So the tan of theta here, right, it's going to be this opposite side, which is 3, over the adjacent. So you get 3/2. But hold on, right? Because you also have to pay attention to the quadrants we're in, right? So this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4, right? So at this point, you should know that tan would be positive in quadrant 3. So I get choice 2 as my answer. I get positive 3/2. Right. So we could talk more about that, about why tan is positive here, why it's the positive one and not the negative one. But I think that we don't have to get into that conversation because by the looking at the choices, like it has to be choice 2, right? Because what we just got. All right, let's keep going. Number 5. The average monthly temperature, T of M in degrees Fahrenheit over a 12-month period can be modeled by T of M, where M is in months. What is the range of temperatures in degrees Fahrenheit of this function? So I think, so because it's asking for the range of temperatures, right? That refers to Y values. So it's just asking me like, what's the possible Y values? I think you could do this on a calculator. That would be one way to do it. But if you've been my student, you know that this is the midline, right? 56 is the midline, right? That 56 is the midline. And then this 23 is the amplitude, right? So you could just imagine a cosine function, right? So you could imagine it like, let's do it like that. So, oh, that's so sloppy. Sorry. So just imagine a cosine function like that, right? A cosine one. But for this one, the midline is at 56, right? So the midline will be here at 56. And now because the amplitude is 23, right? You're going to do 56 plus 23, and you're going to do 56 minus 23. Right? So what's 56 plus 23? 56 plus 23 is 79. And then what's 56 minus 23? Is that 33? Yep. So why did I do that, right? What that's telling you is just checking my text messages. Got a bunch of them there. Probably I'm gonna have to look at those eventually because I know people are checking it on the stream. Maybe they're telling me something's not right. So what that means is the peak here is 79 and that the min here is 33. That's what it means. Okay, so the answer here for me is going to be 33 to 79. I get choice 2 for number 5. Okay, so that's my answer. I think that's it. I would just keep it, I would keep it that simple. Okay, so we've done 5 questions. I'm gonna take like a 1 minute break because I have to plug my charger in and I just want to see these messages. Um, Actually, I don't have any messages, but I do need to plug the charger in. Give me 1 second. I'll be right back. Okay, let me just see how the stream's going. We got any more new people? If you're just joining us, we're up to question 5. There's a chat going on. Use it. I'm gonna be checking it occasionally. I guess like I could check it every 5 questions or so. More new people. If you're just joining us, we're up to question 5. Okay, so there's 4 people watching, which is great. Why don't like leave a comment, say something. Um, what could you say? You could just say, I'm here. Like if you're a student of mine, say, hey, I'm here. If you're a student of mine, say you're here. Or maybe just, if you're shy, you don't want to say your name, just say like the name of the school you go to. I know that I shared this with a couple of my other colleagues. So if you're from a different school, just say the school that you're from in the chat. If you have questions, like ask them in the chat. If I have time, I'll try to answer your questions. Like if you have just like general questions or specific questions about this Regents, I'll do my best to stay on when I'm done with this thing, and answer those questions for you. All right, so we got number 6. So look, I think a question like this, I would go properties of exponents, right? So this is just a to the 1 times a to the 4/5. And so that means you have to add the exponents, right? So if you're adding those exponents, you need a common denominator. So it's going to be a to the 5 over 5 plus 4/5. So then it's just going to be a to the 5 plus 4 is 9 to the 9/5. So it's just choice 2. I just think that's the easiest way to do it. You know, that's how you would do it if you know properties of exponents. Yeah. I mean, if you don't know properties of exponents, I guess you could make up a value for a, like you could say let a equal, um, but I think at this point, if you have to resort to that, I don't know. I don't know if you're my target audience at this point. I could show that strategy like for a different type of question. But let's just move on, right? So this is just properties of exponents. Number 7, what is this expression equivalent to? So yeah, I think this is like a simple, let's go ahead and distribute this. Remember, I squared is equal to -1, right? So we'll keep that in mind. So you got 3i times ai. So that's going to be 3ai squared, right? Because I times I is I squared. 3i times -6i squared. So that's going to be -18i to the 3rd power. So because I squared is equal to -1, you know it can't be this or that, right? Because it's gonna be 3a times -1 minus 18i to the third power, so it's gonna be -3a. So now what is I to the third power equal to? Well, I to the third power is equal to -I. Okay, now this all comes from the fact that I is equal to the square root of -1. Right? I is the square root of -1, right? So if you do I squared, right, that's the square root of -1 times the square root of -1, which is just equal to -1. And then if you do I to the third power, right, that's just going to be -1 times I, right, which you get -I, right? It's just -1 times I. See what I'm saying? Here, could explain it better like this, right? So I to the third, right, you could think of it as I to the second power, just times I. And I to the second power is -1, and then it's just -1i, right? Or just -I. Anyways, kind of drawn out explanation. Sorry about that. So going back to this, right? I to the third power is just -I. So then this is going to be positive 18i. All right, so that's going to be choice 3. Okay, let's keep it going. Okay, I think I got a question on the chat. I knew I was gonna get a question for that. That was not the best explanation. Let me see. Oh, okay. Okay, it wasn't a question. It was just a student telling me they're here. Good to see you here. Shout out, shout out to Miss Halen Stagger. Thank you for being here. Okay, let's keep it going. So we got that was I'm on the right track, right? 8 is the next one. Yeah. Okay, so the next one is 8. Which equation best represents the graph below? So if you look at the graph of log x, we looked at graphs like really early on in the school year. Okay, right, so here's your x and y. It's your x, that's your y. Okay, so if you look at the graph of log x, it looks like this. Okay, that's the graph of log x. Right, so that's y equals log of x. Now, this graph here, right, what you see is that this graph has been shifted, right, from the origin 2 units to the left, right? So it's shifted to the left. Actually, hold on. Let me make sure I'm on the right track with this. I want to make sure I graphed it right. I might have graphed it wrong. No, I'm good. I'm on the right track. Right, so you could see the graph has been shifted to the left, right? And the way that it's been shifted to the left, right? It's been shifted to the left, a units. So if you're shifting a graph to the left, that means you have to add inside the parentheses. Okay, I know that sounds a little counterintuitive, right? But that's how it works when you're inside the parentheses part. So because you shifted this graph to the left, right, you could eliminate choice 2, right, because it's got a minus sign inside the parentheses. And you could eliminate choice 4. Okay. Now, you also see, right, that like the graph is not like the y-intercept is not below the x-axis, so you could tell that it's been like a upshift, right, not a downshift. So from that, I get choice 1, right? It showed this plus is telling you that it was shifted up. And then this plus sign here inside the parentheses is telling you that it was shifted left. So that's my explanation for number 8. Okay, let's keep it going. Okay, number 9, which function has the characteristic as x goes to negative infinity, f of x goes to negative infinity. All right, so what this means, right, as we go, I think the best way, as we go left on the graph, so what this is saying, because remember, the x values, right, the x values, if you're going to negative infinity, that means you're going this way. If you're going to positive infinity, that means you're going this way, right? The x values, think of it as left and right. And then the f of x values, right, that think of it as up and down. So what this is saying, right, as we go left on the graph, f of x is going down. Right, so it can't be choice 1 because the graph is going up as we go to negative infinity. So it's not choice 1, it's not choice 2 either. It would have been nice if they just gave us pictures. Geez, they're gonna make us graph choice 3 and choice 4. Okay, so let's go ahead and do that. Let me go to my graphing calculator. Okay, let's erase that. Hopefully we just have to do this once. All right, so choice 3 says 5 parentheses 4, raise it, was it to the negative x? Yeah. Okay, let's just hit graph on that. Oh, you know what? I think I typed in a subtraction sign instead of a negative sign. Okay, so you see with this graph, right, as you go to the left, the graph is going up. And as you go to the right, it actually has a horizontal asymptote. But anyways, that doesn't matter because we're not even supposed to be paying attention to that. So I already know what my answer is. My answer is going to be the last one by process of elimination. It's going to be choice 4. See that there. Okay, so the answer is going to be choice 4. Right. Choice 4. Because we know it wasn't the other ones. I mean, you could try graphing it too, but at this point, we know it's choice 4, so let's just keep it moving. Okay. Number 10. Okay, the expression is equivalent to. All right, so they are giving you these like long questions, right? Because you could distribute this and then combine the like terms. That would be one way to do it. Let me teach you another strategy. I went over this with my class, right? Whenever you get these equivalent questions, you can just look at their graphs, right? So I think I want to go over that at some point. I want to teach that during this stream. It's like a little test hack. So let me just write it here, right? Look at their graphs, right? Because if the graphs are the same, then that means they're equivalent. So let's go back to the calculator. Let's go to y equals. So what do we got here? We got, it was x squared. X squared plus 3 squared minus 2 x. I can't use the x for my keyboard. X squared plus 3 minus 24, right? So kind of annoying, but it works. So let's just zoom out, make sure we're actually looking at the whole graph. Sometimes these graphs expand like outside. All right, so it looks like it's like a like the highest exponent, right? It looks like the highest exponent is even on this, right? Because the end behavior here, right? If we in fact saw the end behavior. Okay, so having said that, we could examine the choices. Why don't we go ahead and start to use process of elimination? Okay, so the first choice said x squared. So all I'm doing is I'm just graphing the choices to see which one matches the original one. So the first choice says x squared plus 9. This is like a test hack, right? Like the test maker probably doesn't want you to do it this way, but hey, we're just gonna hack your test, bro. You know, they probably just want you to like, they probably wanted you to like factor stuff out. Um, and But so you see it's not choice one, right? Choice one clearly does not match the graph. Um, let's look at choice two. I'm just gonna turn that off. So choice two was x squared minus 3. And then it was x squared plus 7. Okay, graph. That one matched perfectly. So it looks like it could be choice two. And you could check with the other choices if you want. I'm not gonna do that. Because that was like a perfect match. But you could if you want. Let's go back to the whiteboard. So the answer was choice two, right? We got a perfect match with that one. Um, cool. Choice two. Just right, just look at their graphs and just see which ones match with the original one. Okay, what is the solution to this system of equations? I would just plug and check here. Just take the choices, plug them in, and then just go off of that. Plug and check works nicely here. You got 3 variables. So why don't we start? I would start with the easiest choice to check. Like this is a nice choice to check because you got 0, 0, and 2. Like 0 is an easy number. So this one you could see it's gonna work with the first one. Is it gonna work with the second equation? So you got 0 minus 2 times 2 minus 0. So this is gonna be 0 minus 4 minus 0. You're gonna get -4. So it matches with the second one, like right, the left side matches the right side. That's what I mean. And then let's see if it works with the third one. So it's gonna be 0 minus 9 times 2 plus 4. So it's gonna be 0 minus 18 plus 4. So -18 plus 4 is -14. No, it's not choice 3. didn't work with choice three. Right, so it did not work there. So the answer is not three. Let's use a different color for the other choices. That we could try choice four. So it looks like choice four is not going to work either, just like on the first try, because it's going to be 0 plus 2 plus 4 equals 2. And we know that that does not equal that. So it's not choice four either. So it's not choice three, it's not choice four. Let's try choice one. I don't think it's going to be choice one because it's going to be -2 plus 2 plus 2 equals 2. And then that would work actually. So far, that works with the first one. I think I added wrong in my head, and I thought it would not be choice one, but like I added wrong for that first one in my head. But when I actually did the addition on paper, I see that it worked out. So like we have to keep going with choice one until it doesn't match. So -2 minus 2 times 2 minus 2. So that's going to be -2 minus 4, which is -6, and then minus 2, which is -8. So it's not choice one. So by process of elimination, the answer is choice two. I'm getting a message saying that I did something wrong. All right. I'm getting a message saying that something is not right. So I should start again. My bad. I think I made a mistake when I was checking with number three. I did make a mistake. I made a mistake. I made a mistake right here when I was checking with choice three. So I wrote 0 minus 2 times 2. No, that was fine. But someone's telling me that I made a mistake when I checked it with choice three. So let's check with choice three again. See if we find the mistake. All right, so choice three with the first equation, it's going to be 0 plus 2 plus 0 equals 2, and that works out. With the second equation, it's going to be 0 minus 2 times 2 minus 0 equals -4, and that works too. -4 equals -4. Okay, and now here it's going to be 0 minus 9 times 2 plus 4 equals -18. So it's going to be 0 minus 18 plus 4 equals -18. So I get -14 equals -18. I get the same thing again, but that's not right. But someone told me I made a mistake. But did I make the same mistake again? Let's see if we can figure this out. Am I typing something in wrong? 0 minus 9 times 2 plus 4. 0 minus 9, that's -18. -18 plus 4 is -14. That doesn't work out. Hold on one second. I'm gonna have to check with the regents, make sure I'm doing this right. I guess I was doing it right before and someone told me it was wrong. What question number is this? Number 11? All right, so for number 11, so for number 11, it says the correct answer. So the New York State Regents website doesn't, I don't see the multiple choice answers on there. They just have like the part two, part three, and part four. Just bear with me 1 second, maybe. I'm not seeing it. Well, I feel like I was on the right track. 09. Let me see what you guys are saying on the chat. See if anybody's got the right. If you could help me out on the chat for that. You're watching and you could help me out. Okay, I got nothing on the chat yet, but if you could find the official answer to that question. Because I'm not finding the official answer. Um, let me see. That was question 11, right? June, so it's the June 2023 question 11. Okay. Well, I'm gonna use technology actually. I'll show you this little technology trick. Just because need it, I need something really fast. I'm just gonna go on Chat GPT here, and I'm just gonna say, what's the answer to this? I took a screenshot of it. Um, and then I just wrote, what's the answer to this? See what Chat GPT says. Obviously, you can't do this during the test, but I could do this now. And so you could see Chat GPT is doing what I did. It's just checking with each of the choices, checking each of the options. Um, so right, so it's checking with each of the choices. Um, it says the correct option is option 3. I was corrected, right? Somebody told me it was option 3. So I stand corrected by that person and by Chat GPT. The correct answer is choice 3. Let me see where my mistake was. Oh, okay. I found my mistake. Do you see it? I don't know why. Right. So, wow, this is like a horrible mistake to make. Did you catch it? So when I was plugging in, I wrote 0 minus 9 times 2 plus 4. I don't know why I wrote plus 4. Clearly, like here, z is 0, right? I should be writing negative 9 times 2 plus 0. So I don't know why I did that. I don't know why. That was clearly wrong. So I was able to see when I used Chat GPT, which you're not allowed to do during the test, that you see here when I checked option 3, I noticed it, right? They wrote 0, it wrote 0 minus 9 times 2 plus 0. I kept writing plus 4. I don't know why I kept doing that. Where was I getting the 4 from? I have no idea. But I also just taught you a study tool, right? How to use AI to check yourself as you're studying for this test. Okay, let's continue. So number 12, what are the roots to this thing? So first thing you need to do with number 12 is you have to put it in standard form, okay? So it's going to be x squared minus 4x plus 13 equals 0. And then for this question, by looking at the choices, I think your best approach is just to use the quadratic formula. So A equals 1, B equals -4, C equals 13. Okay, so the quadratic formula, I'll write it here, is x equal. Oh, by the way, you don't have to memorize it. It's given to you in the Regents. I went over this with my class, what you get in the Regents, what you don't get. But they do give you the quadratic formula. It's all the way in the back. All right, so it's gonna be 4 plus minus -4 squared minus 4 times 1 times 13. Sorry, it's a little sloppy. Over 2 times 1. Okay, so then it's just going to be 4 plus minus 16 uh minus 4 times 13 should be 52. Is that right? Over 2. And then we got 16 minus 52. It's -36. So it's going to be 4 plus minus, right? So it's -36. Let's just save ourselves the time, right? So the time, so what I mean by that is, right, -30, the square root of -36 is 6i, right? It's 6i because it's got a negative under the radical. So let's just write the 6i now, save ourselves that time, over 2. And then this is just going to be 2 plus minus 3i. So the answer is choice 1. Okay, let's go to number 13. Which expression is equivalent? So remember that graphing calculator trick I showed you? Whenever you see this equivalent thing, you could just graph, like see like which one of the choices matches the graphs, matches the graph of the original, right? Which one of the choices matches the graph of the original? You can use that approach here. Or you could do long division. But I think, you know what? I'm gonna do the calculator hack because I think I'm gonna show long division at some point anyways. So I don't feel like doing long division right now. So let's just use the calculator trick. All right, so let's graph the original. So it was 2x cubed, 2x cubed plus 2x minus 7 divided by, see the use of parentheses too, right? 2x plus 4. Okay, see what that graph looks like. All right, that's what it looks like. And then let's just start graphing some choices. So choice one is x squared minus 2x plus 5 minus, and I'm going to use parentheses for this. Okay, it's going to be, I'm using parentheses, right? Because it's got to be the minus like the result of the division, right? The result of 27 divided by 2x plus 4. You know, so you could do the parentheses like that. Okay, I'll show you another way. Let me show another way. There is a way to get the fraction. If you go to, I know I showed this to my students. I think it was it? It was, yes, so it's alpha y equals, right? And then just option one. And then you get the fraction bar, right? So minus 27 7 over 2x plus 4. Okay, graph. Perfect match. You know, and you didn't you didn't have to do long division. You know what I'm saying? You didn't have to do long division, and it was choice one, so that worked out nicely. You didn't have to do it for all the choices. If you're a teacher and you're watching this, you're probably, maybe some of you are upset that I'm showing this way. I do think it's important to teach the long division way, and I'm going to do that at some point. But I also think it's good to just match the graphs. So it's option one, using the graphing calculator hack. All right, let's keep going. Let's keep going. Number 14. All right, it's been an hour right into this, so sorry it's taking so long. I'll try to speed it up. What do they want here? They want a regression model. So, right, so you were given a table, popular celebrity, tracks the number of people in thousands who have followed her on social media. Summary of the data recorded is shown below. Okay, so you got X values, you got Y values. The celebrity uses an exponential regression equation to model the data. According to this model, how many followers did she have on June 1st, 2018? So just to be clear, right, because this is since 2015, right? This is like the number of, see how they're kind of trying to trick you, right? This is the number of months since January 2015. So this is, so if you think about it, right, this is January, right? Number of months since Jan. So this right here is trying. So when it says number of months since, um, all right, let's just get the calculator and then we'll worry about that stuff later. All right, so all right. Go to second stat plot. Or was it? Right, so actually you don't need second. You just press stat, no second, then go to edit. And then we're gonna clear these values, clear that, and we're just gonna enter the values here. So we got 2, 11, 16, 20, 27, 35, 47, 50, 52. And then the Y values, 3.1, 7.5, 29.7, 49.7, 200.3. 680.3. 203. 8109.3. Okay, 12107.1. All right, so now we got to do the exponential regression. Okay, so you're gonna go to stat, calc, and you're gonna go to exponential regression. You're gonna look for exponential regression, right? So it's option 0, and you're gonna tell the calculator you want it to make the regression. You want the X list to be L1, the Y list to be L2, and you're just gonna hit calculate. So it gives you this equation. Okay, so show you how this works. I wish there was a way to just go straight to my whiteboard from here. So, but there isn't. I have to hit stop share and then go to my whiteboard. Kind of annoying the way Zoom works. So, okay, so all right, so from the exponential regression, right? And it's also nice that the TI-84. So if you could use a TI-84 for the test, make sure you get a TI-84 because it gives you the model, right? It says it's Y equals AB to the X. And then it gives you those values. So it says A equals 1.767. So Y equals 1.76. What did I say? I forgot already. 1.7676. Did I say 9? No, 1.67. See, my memory is horrible. 1.767. And then I'm just gonna round that 7 to an 8 because I'm just gonna round to the nearest thousand. 1.768, and then it says the B is 1.185 if you round it 1.185 if you round it right to the X. So now because it wants June 2018, you have to think about how many months is June 2018 from January 2015. It's really annoying to the test maker, right? That you would do this. You should do this. Jeez, right? Because now you got to think about how many months since January 2015 is June 2018. That's so annoying, bro. So I mean, you could just so you could do January 2015 to January 2017, and that's 12 months, right? And then to January 2018, that's so to sorry, that's I gotta write this out. January 2016, right? And then the next one is January 2017, and then it's gonna be January 2018, right? So what I'm saying to you, right? So from here to here, that's 12 months. From here to here, that's another 12 months. You see what I'm saying? So what's that so far? 26. Oh, and it started at 2015. Whoopsie. So 2015 to 2016, 12 months. Right. So you got 12, 12, 12. That's 36 months so far. And then it goes to June. So 12, 12, 12, right? That's 36 months. So January 2018. Then you got February, March, April, May, June. So you got to do plus 5, 36 plus 5. So it's 41 months. So June 2018 is 41 months since January 2015. So you have to use that for X, right? So X is 41 months. So you're gonna do Y equals 1.768, 1.185 to the 41 power is what we're gonna do on the calculator. Okay, so let's do that. Okay, so let's quit there, right? So it's gonna be 1 point, what did I say? What did I write down? 1 point, I gotta pull it up from the whiteboard. Don't tell me that. 1 point, what was it? 768. Then the other one was 1.1. Hold on, I gotta pull it from the whiteboard because I forgot the numbers already. I'm gonna check the chat in after this question. So if you have questions, feel free to put them in the chat now. Um, tell me how the sound quality, like if you could hear me well, I just want to make sure the sound quality is good. So the other one was 1.185. 1.85. Okay, so now I gotta share my calculator again. Five. And then we said raise it to the 41 power. 1.768. And then 1.185. Raise it to the 41 power. All right, so that's, so I get 1861. I get about 1861 in the thousands, right? Because you have to remember the way this was in the original problem, right? The number of social media followers is in the thousands, right? So you could think about multiplying this by 1,000, like if you want to get the actual number. So it's about 1.861 million. That's what it is, okay? So having said that, right, this is all an approximation. Okay, this is all, these are all approximations. So you're gonna have to, you have to pick the answer that's closest to your answer. So I know the answer we got was, what did I say? I think I said 1 point, I could pull it up again. What would I say? 1.861,806, right? Is what I said. 0.54, right? So the closest one is choice 3. So I'm gonna go with choice 3. All right, let's check the chat, see if we still have people here. Yeah, we got more people watching. Yeah. Yeah. Oh, Halen, thank you for your participation. Yeah, it was choice 3. We fixed that one. All right. So 6 viewers, guys. Yeah. We're moving on up. Share this with your friends if they're taking the Algebra 2 Regents. Um, let's try to get this up to 100 views before the test on Monday or something. I don't know. Help me out here. Okay, let's keep going. I know it's taking a while, right? Let's keep this thing going. So let me know if the sound quality is good. Just say sound quality okay or something. I just want to make sure that you guys could hear what I'm saying. I guess there's still 6 viewers, so that means you could hear me, right? Um, just say yes. Like if you could hear me well, just say, I guess you could hear me well. Somebody just responded on the chat with will do. Sorry. So the sound is fine. Is the sound okay? Should I be louder? Okay, thank you, Hit. Thanks for letting me know. Okay, I just lost my pen. Okay, I just grabbed it now. All right, I guess the sound quality is fine. I guess you could hear me well. Okay, so I'm gonna keep going. Oh, you know what? I guess I could write something in the chat. I'm gonna say, just in case people come by later, maybe they could read my message. Thanks for coming. Thanks for coming to my live. Leave me a message. I will try to answer later. Okay, thank you, Halen. The sound is fine. Okay. All right, let's keep it going. So we got number 15. Luminescence is the emission of light that is not caused by heat. A luminescent substance decays according to the function below. Okay, the function can best be approximated by. All right, let me see what we're working with here. I got to read that thing over. Luminescence is the emission of light that is not caused by heat. Luminescent substance decays according to the function below. All right, so because because this is like an approximation type thing, you could do the calculator hack here. Geez, man, if you took this test last year, there are so many questions you could have used the calculator hack for. It's like crazy, right? Because you could just graph this, right? Graph this, and then you could just see which of the choices most closely matches with that one. So I think I have an idea of what it can't be. And I guess I want to talk about that. I want to say why it can't be like certain choices. So for example, like I know it can't be choice one because if you do choice one, this is gonna you see how it's got this. You see how the original choice has this three here, this 3 times negative t over 0.6. Like this is equal to I sub 0 e to the negative 3t over. So it's just that 3 times that negative 1t. It's equal to I sub 0 e to the negative 3t over over 0.6. That's a 0.6. I'm sorry, that's sloppy. So I know it's not going to be choice one. And I know it's not going to be choice two either. It's going to be choice three or choice four. Um, so it's either choice three or choice four, right? So I'm actually thinking, you know, you could do the calculator hack. We could just figure out what this is. This negative 3t over 0.6. Yeah, it's gonna give a negative value. And I think let's do the calculator hack. All right, y equals. Okay, so I'm gonna graph. I'm gonna graph the original one. Oh, actually, I'm gonna have to make up a value for I sub 0 because they didn't give a value for that, right? So I'm gonna say let I sub 0 equal 2, right? So in my graphing calculator, I'm gonna do 2 to the 2e to the negative 3t over 0.6, and then I'm gonna see which one matches the best. Okay, so all right. So I said I'm gonna do. See, that's the problem. I have to go back to my whiteboard because I forgot already what I wrote. I think I said 2e. Hold on, I think I can remember. Try to remember, Rick. 2e to the, what was it, negative 3 over 0.6. Okay, that's the original. Forgot the t, which in this case it has to be x. Second insert. Okay, x. No, don't do that. 3x. Okay, hit graph. Okay, that's the original graph. Let's do a zoom 6 on that. Okay, that's the original. And then, so then the second graph, meaning like choice 3, right? We already said it's not choice 1, it's not choice 2. So now choice 3 is gonna be 2e. Oh, there's no e, my bad. 2 point 0067, raise it to the x. That's pretty close. That's pretty close. So we could try it with choice 3. Sorry, choice 4. My bad. With the last choice. 2 point 0497. And then it says raise it to the 0.6x, hit graph. Yeah, it's not that one, right? So you got your answer. So, all right, let's pull it up. We said it was choice 3. Oh, wrong whiteboard. Calculator hack to the rescue, man. Okay, let's keep going. The heights of the students at Central High School can be modeled. So just so you know, we're gonna take a break after the multiple choice. And I'm gonna keep going. I'm gonna keep going until I do the whole thing. And I guess if this is too long for YouTube, they'll tell me. I'll figure out a way to edit the video. Okay, the heights of the students at Central High School could be modeled by the normal distribution with a mean of 68.1 and a standard deviation of 3.4 inches. According to this model, approximately what percent of the students would have a height less than 60 inches or greater than 75 inches, right? So I taught my class how to do this on the graphing calculator. Let me see if I remember myself. So I believe the way I taught this, I forgot myself. I think I might have to look. I might have to look at my notes. Um, was it stat calc? Oh, this is annoying. Be there. It has to do with statistics. So let's check our statistics menu. It's not that. It's not a regression. Hmm. Let me see if anybody in my chat remembers. See if anybody in my chat remembers. No, I got nothing on my chat yet. Okay, give me a second to pull up my notes. This is, yeah, I think the best way to do this is to just do this on the calculator. Like it just asks you for the mean, it asks you for the standard deviation, and then you just state on what parts you want it to give you you just select like what parts, like the low range and then the high range. Okay, so I'm just gonna pull up my notes. Okay, this is like the normal distribution topic. Um, okay, let me see if I can have the instructions here. Okay, I got it. All right, so it's you ready? So it's second vars Okay, so it's second vars. And then we're gonna go to the distribution menu. Okay, so we're already at the distribution menu, and then we're gonna go to option 2, normal CDF. Okay, so you give it the lower boundary. So from the problem, it said the lower boundary was 60 inches. It says would have a height less than 60 inches. Let me read that again. According to this model, approximately what percent of the students will have a height less than 60 inches or greater than 75 inches? Oh, actually, you know, the way to do this one, we might have to do it twice. Um, it's gonna be kind of annoying. We're gonna have to do it twice and then do like an addition type stuff. Okay, let me, I have to talk about this one. This one's a little more tricky. Okay, we have to say more. All right, so let me go back um and explain a little more for this one. This one's a little more intricate. Okay, this is algebra 2, all right? This is not, it's not always, so black and white. So remember, a normal distribution bell curve, right, looks something like this, right? And then you got your mean right at the middle, right? Your mean is right here at the middle, which was a mean of 68.1. 68.1. Do that over. Right? Okay, so then you have a standard deviation of 3.4 inches, right? So 68.1 plus 3.4 is what? 68.1 plus 3.4 is 71.5, right? So like plus one standard deviation is 71.5. And then minus a standard deviation. So 68.1 minus 3.4 is that 68 minus 1 minus 3.4. So that's 64.7, right? So this is like minus one standard deviation, 64.7. So now here is asking for, right, less than 60 inches. Right, so that would be like, let's just estimate it, right? That would be like this part here, right? About that part, right? About less than 60 inches. So you have to figure this out, like, right? What's that? Like, what percentage is that? You gotta calculate that using the calculator. And then it's also asking for greater than 75 inches. So where would 75 inches be, right? That would be like about here. So now you got to calculate that part and then just add the two percentages. That's why this question is going to take a little more time. But once you figure out what you have to do, it's pretty quick. Okay, so all right, so let's go to the calculator. So less than 60 inches, right? That's like from 0 all the way to 60. And then the mean height was 68.1. And then the standard deviation was 3.4. Okay, so let's do that. So we get this number, and now we have to do it again for greater than, what was it? Greater than 75 inches. So that's going to be from 75 inches, from 75 inches and up. So just pick like a big number, for the upper, I don't know, like 100, 1,000. I mean, nobody will ever be 1,000 inches, but you just got to pick a big number. That's all. So the mean was, so I forget these numbers. what was the mean? Okay, 68.1. Okay, it's already there. The standard deviation. Oh, it was there from the last one. Okay, so you get these two numbers, right? You got this number, 0.021, blah, blah, blah. So let's add that number. Maybe you can just hit plus. Yep. So see, if you just hit plus, it will take the previous answer plus 0.0086011,897. Hit enter. Multiply it by 100 to convert it to a percent. And you get about 2.98, which is about 3%. Fingers crossed. I hope that's a choice. So 2.98 is a choice. So the answer is choice 4. Okay. So choice 4. Come on. Where's my pen? All right, that's 16. Okay, let's keep going. Keep it going, keep it going. Keep the momentum going. All right, we'll take a break after the multiple choice. We'll take a 5-minute break. All right, I'm trying to pick up the pace. They take a while. That's why it's a 3-hour test. Okay, Marissa and Sydney are trying to determine if there's enough interest in their school to put on a senior musical. They randomly surveyed 100 members of the senior class, and 42% of them said they would be interested in being in a senior musical. Marissa and Sydney conducted a simulation of 500 or more surveys. Each of 100 seniors, assuming 42% of the senior class would be interested in being in a musical. The output of the simulation is shown below. The standard deviation of the simulation is closest to, okay, so they just want the standard deviation. So, you know, the way to do this, right? If you remember the bell curve, all right, so this is the way I taught it to my students. You know, they just want to see how well you approximate in this question, right? Doesn't have to be exact. If you look at a, jeez, sorry about that. If you look at a normal bell curve, right, you got the mean in the middle, right? And then if you go +2 standard deviations, okay, so if you go +2 standard deviations, right, you'll be here. And if you go -2 standard deviations, you're here. This is about 95% of your population. Like 95% of your population is within 2 standard deviations. So if you look at this thing, right, if you look at, right, think of that as a normal bell curve. You could say that there are, there's 95% of your population is within these boundaries, right, that I just selected there, about 95%. And so from 0.44, I'm going to assume that's the mean. So from 0.44 to here, that's +2 standard deviations, right? So from 0.44 to let's go with that 0.32, that's about 2 standard deviations. Okay, so we're just gonna do some very simple math here. So it's basically, right, it's like this 0.44 plus 2, let's go with the plus 2 times some number is supposed to give us this 0.52. Like, figure out what that number should be. So it's going to be 0.52 minus 0.44 divided by 2. I get about 0.04. is what I get for my stand. Like I'm right, I'm saying this number here, this missing number here has to be 0.04. So I'm gonna go with choice two. It's the closest one to my answer. Right? It's asking for the standard deviation. And I think that's a, it's a pretty accurate approach, right? It's like closest to, right? So, it's not the best approximation, but that's the closest one there. Right. And I think the way to do it is you have to think like plus two standard deviations, minus two standard deviations. That's where 95% of your data is, right? And so I'm looking at all this and I'm saying, okay, I think 95% of the data is roughly here and here, roughly. And then you just kind of have to just guesstimate a little bit. Okay, number 18, for f of x equals the cosine of x, which statement is true? Okay, let's see. Um, so for this, so we're looking at even and odd functions. Okay, so I think a visual approach here would work nicely because we learned that a function that's even, right, is symmetrical about the y-axis. Okay, so what I mean by that, let's get our calculator, right? Let's give you a visual. Let's erase this stuff. All right, so what I mean by that is, right, if you graph the cosine of x, okay, it's right now it's symmetrical about the y-axis. Okay, let me clean up the window a little bit. Let me make it -5. No, I want to leave that at -10, but it's the y values I want. Want -5, 5. I just think it looks better this way, right? So is Zoom gonna let me annotate here? Okay, it is. Okay, so you see here's the y-axis, right? And what we're saying is that this graph is symmetrical. Okay, so it's like this part would reflect right up to this part. You see what I'm saying? This would reflect right there. Is that too thin? Right? Like this point reflects perfectly here, right? Like it could fold onto itself. You could fold it across the y-axis onto itself. That's an even function. That's a good way to think about an even function. So choice one is saying, okay, let me stop annotating. So if you go to y equals, so choice one says it's 2 cosine x symmetrical about the y-axis. It is 2 cosine x, right? If you put a 2 in front of it, if you make it 2 times f of x, is it symmetrical? It is. It's still symmetrical. Well, what if you put the 2 inside the parentheses? What if you make it cosine of 2x? Is that still going to be symmetrical? And it is symmetrical. Let me just erase those dots I had from before because they might be a little distracting, right? But you could see that it's still symmetrical. Like this point, right, reflects perfectly here. Like you could still fold it onto itself about the y-axis. Okay, so I don't have to keep checking the other choices. I could see that the answer is already going to be choice one, right? It's not going to be choice two because we just checked it and we saw that it's going to be an even function because it reflects perfectly about the y-axis. Odd functions, that's something else. We could talk about that later if it comes up. If you want to know what that looks like, you could ask it in the chat and I could go over it. Otherwise, I won't go over it if it doesn't come up. and you don't ask. Just kind of trying to show what the answers are here and how to get to them in the most efficient way. Okay, so that's 18. Keep going. Number 19, we're going to take a break at the end of the multiple choice. All right, the solution set to this. All right, let's use process of elimination. We know the answer cannot be 5 because 5 will make this denominator undefined. So the answer cannot be 5, so it can't be choice 3. The answer cannot be -2 as well. The answer cannot be -2 and it cannot be 5. So we're just left with these, and so it can't be choice 2 and it can't be choice 3 because they're both including 5 as an answer. So then what could we do? We could use a plug and check method. That would be one way to do it. So why don't we check? Why don't we do plug and check? So let's start checking with, should we check with 6 first? We could check with 6. So it's gonna be 6 plus 3 over 6 minus 5. I picked 6 because it's a positive one. It's just easier to start with that for me. So 6 plus 2 equals 6 plus 10 times 6. And then 6 minus 5. And then 6 plus 2, right? So I could do this. We could do this in our heads. So this is going to be 9 over 1 plus 6 over 8 equals, and then this is going to be 6 plus 60, 66 over, this is going to be 1 times 8 over 8. So it's a matter of checking if this stuff is equal. So let's multiply this by 8. And let's multiply this by 8 because we need a common denominator. So this is going to be 72 plus 6. 72 plus 6 is 78. So it's 78 over 8. That's not equal to that. So I know the answer can't be 4. So it's got to be choice 1 by process of elimination. Okay. So just plug and check is what I did. I know the answer cannot be 6. So choice 4 cannot be an answer. So it gets eliminated. Okay, number 20. Given x and y are positive, which expressions are equivalent to x to the third over y? This is a question where you could do plug and check. Like you could make up values for x and y, and then check that way. I said I would show that approach, so I kind of like, I want to go over like how to use that because I don't think I've gone over this type of approach in the other questions. So I'm going to do that here. Okay. So you have to make up a value for x and y. Never use 0 and 1. Never use 0 or 1 for these types of questions. So let's say let x equal 2 and let y equal 3. So that would mean the original expression, if we let x equal 2 and y equal 3, the original expression is equivalent to 2 to the third power over 3, which is 8/3. So now I got to see which of these options is equivalent to 8/3. So now the first option is going to be 3 over 8 to the -1. And that's just equal to 8/3. So that worked out. So the first one is equivalent. Okay, so you see I substituted 3 for the y, I substitute 2 for the x, I get 3/8. If you're raising something to the -1, you just flip it to get rid of the -1 exponent. All right, now this is going to be kind of annoying to do. Choice 2 is going to be kind of annoying. let's get our calculator for that. Not gonna bother trying to work that out. Just gonna get the calculator to do it. So it said, let's see what it said. It was x was equal to 2. So it's gonna be 2 to the 9/3. I'm gonna explain how I got 9/3 in a second, okay? Don't worry. And then times it was y to the -1. So y was, what did I say? Y was equal to 3, right? So 3 to the -1. All right, see if that gives me 8/3. That is 8/3. I think that's 8/3. Yeah, it is 8/3. Okay, so choice 2 works as well. Let me explain how I was able to convert that to 9/3 real quick. So the way that I did that, let's go over this property. So x, so the nth root of x to the m is equal to x to the m over n, right? So I basically converted this to x to the 9/3, and then, I did times y to the -1, right? So that's how I got 9/3. I used this property. Okay, so choice 1 and choice 2 work. So I know the answer cannot be 3 because it's missing choice 1. And I know the answer cannot be 2 because it's missing choice 2. I know choice 1 and choice 2 works. So it could be choice 1 or choice 4. Um, this is going to be annoying, but let's just do it, right? So we said x is 2, so this is 2 to the 6th power, and then this is going to be y to the 8/4, which is just y to the 2nd power. So let's just change that now. Over 2 to the 3rd power, and then y to the 3rd power. Let's change the y's since I already did it for the x's. Okay, so we said y was equal to 3, right? So this is going to be 3 to the 2nd power. And then you got 2 to the 3rd power. And then we said 3 to the 3rd power. Okay, so 2 to the 6th, 3 to the 2nd, and then 3 to the 3rd. So, I mean, I could do this in my head, but I'm gonna just show it on. So for the teachers that are watching this, like, I know I keep going back to the calculator. Like, this is really more for students, and I'm targeting like my middle students, that might struggle with a little bit with computation. So that's why I keep going back to the calculator. Um, so let's go back to the calc. Geez, I forgot already what I wrote. Try to remember. It was 2. I'm gonna pull up the fraction bar. Alpha y equals 1. So we said it was 2 to the 6th, and then it was 3 to the 2nd, right? It was y to the 8/4. So 8/4 is just 2. And then in the denominator, we had 2 to the 3rd. And then we're just checking that whether or not this equals 8/3. And then it was 3 to the 3rd power. It equals 8/3. So you saw it there yourself. So the correct answer here is choice 4. Okay, so number 20 is choice 4. Okay, let's keep it going. 21. So we were given the inverse function. And we want to go back to the original. Okay, so the way to do that, right? So you have y equals 2/3 x plus 1/6, right? The way to do that is you got to find the inverse of the inverse to go back to the original. So the way I taught it, right? You switch x and y. So I taught this early on in the school year, so maybe it's been a while for some of you guys. You switch the x and y, so you're gonna get x equals 2/3 y plus 1/6. And now you just gotta solve for y. So it's gonna be so minus 1/6 minus 1/6. So you get x minus 1/6 equals 2/3 y. So now I gotta multiply both sides by 3/2. So these cancel. 2/3 cancels with 3/2. See. Okay, so gotta distribute this, right? So you get 3/2x minus 3/12. 2 times 6 is 12 equals y. Simplify the 3/12. What's that? 1/4. So you get 3/2x minus 1/4. So the answer is choice 3. 3/2x minus 1/4. Yep. Okay. Number 22. Okay, we're almost done with the multiple choice. We'll take a 5-minute break at the multiple choice mark. Okay, so 22. Which of the following, how many equations below are identities, right? So that just means left side equals the right side. You could use plug and check here. You could make something up for x and y. Not sure if I want to do that. Trying to see the best approach. I might just do that. I might do that again. Let's just let's just do that. This is getting, you know what this is like, right? This is like when a football team has like a really good running back, and it's like, what's that team gonna do next? Are they gonna throw the ball? No, they're just gonna run the ball every single time. They're just gonna ground and pound you, right? I mean, we have a strategy. We know it works, right? We know that you could say, let x equal 2 and let y equal 3. And then we're just going to see what matches and what doesn't match, right? We're just going to use ground and pound until you give me a different type of question, right? Like this is not a knock on you. This is a knock on the test maker. Like they're making their test hackable. So if you do this, right, on the first equation, it's just going to be, the left side is going to be 2 squared plus 3 squared, which is 4 plus 9, which is just 13, right? So, does this equal 13 if you let x equal 2 and you let y equal 3? Let's see. Let's put it in the calculator. So it was 2 squared minus what? 3 squared. I don't think it's going to work actually, because that's going to give you 2 squared minus 3 squared is going to give you a negative number. I could still work though, actually. I thought it was multiplying by the 2xy. So 2 and then times 2 times 3 And then that's gonna be raised to the second power. Okay, so if you want to see what I typed into the calculator, okay, I'll show you. Um, Here it is, where's my calculator? That's what I typed in, right? So 2 squared minus 3 squared. 2 squared minus 3 squared, and then plus 2xy, 2 times 2 times 3 to the second power. You don't get, you don't get, what were we supposed to get? 13, I said, right? You don't get 13. So let's go, let's bring it back. Um, I don't know. So it's just a lot of stuff going on here on the Zoom end. Sorry, it takes a while. Thanks for staying with me. I mean, kudos to you. If you're still on this thing, I didn't know it was gonna be on this long, right? So this is not an identity because, right, the left side was 13, and then on the right side, we got 139. So it's not this one. Okay, so let's do it for, um, so that already tells you right there, right? So the answer cannot be choice 3. The answer cannot be choice 1. It's either choice 2 or choice 4. So we just have to try it for one more. So let's try it for this one here, right? So we're gonna do 2 to the third power plus 3 to the third power. So that's gonna be 8 plus 27. So that's equal to 35, right? So the left side is 35. So we have to see, will this equal 35 if I let 2 equal x and I let 3 equal y? Okay, let's see. Let's pull up the calculator. Right, so remember, so we're looking for 35, right? We want it to equal 35. Um, so it's gonna be 2 minus 3, negative number, plus, what was it? 2 squared minus xy, so minus 2 times 3. Then plus 3 squared. Yep. Does this equal 35? No, it does not. Does not equal 35. So so the answer is not, so the first one didn't work, the second one did not work, right? So the answer cannot be choice 2. So I'm left with choice 4. So choice 4 is the answer. So the answer is like none of them. Oh, actually, I guess one of them could still work. I should not have eliminated choice 1. Because technically, right, this last one could work. So I have to check. So hold on. I have to check. I was in a little bit of a rush. I have to check if this works. So, okay, so I gotta do 2 to the 4th plus 3 to the 4th. And let's do that on the calculator. Try to do it faster this time. So 2 to the 4th plus 3 to the 4th. 97. Okay, let's see what the right side equals. So you're gonna have to do 2 minus 3. 2 minus 3. That's gonna be a negative times a negative, and then it's gonna be 2 squared plus 3 squared. So, we gotta check if this equals 97, and it doesn't equal 97. So actually, I'm still right. none of these equations are identities. So far, my review, so it's still choice four, right? None of them are identities. My review of this test so far is kind of annoying. It's kind of annoying for a test, but at least they're giving you questions that are doable. You could use the calculator hack for a lot of them. Okay, focus and directrix of a parabola. Now, this is not a question that, if you're my student, we didn't do focus and directrix of a parabola. All right, so my bad. You don't really have time for a lot of this stuff. And it's just one question on the whole thing, and it doesn't really always come up, but if it comes up, just know that I didn't cover it. I'll sort of cover it now. I'll give you something that you could work with. So it says the focus of a parabola is 0, 6, and the directrix is y equals 4. What is an equation for the parabola? So the way that you could work on this problem. So, you know what I think? I think if you're my student, you could think of it like this. Where's my pen? And so it's like you have a parabola, right? The directrix, right, is just this horizontal line that's below it. Right, that horizontal line is y equals 4. And the focus of the parabola is just basically up here. It's 0, 6. Right? So I want you to just kind of ask yourself this question here, right? This distance from here, like this 4 to 6, right? That distance there is 2. So from the focus to the vertex of the parabola, that's 1. So we're just gonna go with p equals 1. Okay, and then the y-intercept, right, is just gonna be 0, 5. So we have like we get this equation, right, where it's just like y minus the y-intercept, which is 5, equals, and then it's just gonna be 1 over the directrix times the value, and it's just gonna be, there's no shift left. Whoops, sorry, it's doing that. Oh, no, don't do that. There's no shift left or right. So it's just x minus 0 to the second power, right? So this is the equation we get. I know this is not the best explanation, and it's like probably not really, it's really not the best explanation. But if you simplify this, you're going to get option 2. If you're my student, we didn't cover this topic. It may come up, they may throw one question in there like this. Don't sweat it. Don't sweat this topic. If you're my kid, you missed this, it's fine. That's about the only topic that I didn't cover. Okay, the last multiple choice question. John and Margaret deposit 500 into a savings account for their son on his first birthday. They continue to make a deposit of 500 on the child's birthday, with the last deposit being made on the child's 21st birthday. If the account pays 4% annual interest, which equation represents the amount of money in the account after the last deposit is made? So $500 put into a savings account on the first birthday. And they are depositing, they keep putting in 500 each birthday. With the last deposit being made on the child's 21st birthday. So if you think about it, right, this question, right? If you start with 500 and you don't deposit anything else, like no other deposits are made, and the interest is 4%, right? So it's gonna be 500 times 1.04, and then 21 time, raise it to the 21 because it's 21 years, right? This would be the equation if you just make one deposit, which you see is choice one, but the answer cannot be choice one because they continue to make a deposit on the child's birthday, right? So they're putting in money into the account every time the child has a birthday, right? They're putting in money the first time, this, for his first birthday, his second birthday, third, so on and so forth, right? Until the child is 21. So this formula is not going to work. This formula is just giving you interest on the initial 500. This formula here, choice 3, is giving you interest on the initial 500, and then it's just adding another $500. So it's not going to be choice 3 either, right? Because they think about it like this, right? They deposited $500 each time. So it's not choice 1 and it's not choice 3. Okay, so we're left with choice 2 and choice 4. So now I want to see, I don't think they would give a formula for this thing in the back. And I guess the other thing that I'm noticing is because you're left with these two choices, it's like we could just use process. So let's just use process of elimination here. You see how these choices are different? This choice has a 1.04 here, and this choice here is just 0.04. So now that's gonna help us. I like that, right? If you look at choice 2 and you distribute the 500, right? This is gonna be, oh, let's do that thing again. Don't do that. Let's distribute the 500 in the numerator, right? So that's gonna be 500, then minus, it's not gonna be minus, right? It's gonna be 500 times 1, you get 500. And then here, it's gonna be 500 right? You got this 500 times 1 negative times negative 1.04 to the 21 power, right? Which is going to give you a positive number. So you see what it's doing here is you're getting interest on each of the 500s that you're depositing. So I'm going to go with choice 2 on that answer, on that question. Okay, that's my explanation for that one. Because if you distribute the 500 here, right, it's just going to be that 500 times that 0.04. And so that's only taking 4% of the 500, right? You want to make sure you get that, you have that 1 in front of it to get that interest on each of the 500s. Okay, that's the multiple choice. If you have questions, leave them on the chat. We're gonna take a 5 minute break and I will be back in 5 minutes. Let's put a timer up. 5 minute timer. And I will see you guys in 5 minutes, okay? Try and speed it up. Okay, hold on. Okay. See you guys in 5 minutes. So Okay, we're back. We're live again. So again, leave questions on the chat. I'll try to answer them later. And let's continue. Actually, I have to find my pen. Wait, where's the pen? Here it is. All right. Um, um, all right. Let's see if I can just pick up where I left off. Okay, so so we got 5 people on the live. So it's good to have you guys. We're gonna now continue with the short response. So that's part 2, part 3, part 4. We got to show work for these questions. Um, all right. So let me go to my whiteboard. Start a new whiteboard. And I hope you guys are doing well today. Remember, for the test, you're gonna need your calculator, right? I prefer that you use the TI-84. Okay, so make sure you get to the test on time. Make sure you're there on time. Okay, test is Monday. Don't forget. Make sure you get a good night's sleep. Just I just still need to kind of upload the questions, but I think I could just start. All right. So, okay, so here's question 25. 2-point question. The business office of a local college wishes to determine the methods of payment that will be used by students when buying books at the beginning of a semester. Explain how the office can gather an appropriate sample that minimizes bias. Okay, so let's look at the situation again, right? The business office of a local college wishes to determine the methods of payments that will be used by students when buying books at the beginning of a semester. Right. So it's just like, do students like, do they want to use like Venmo, cash, credit card, whatever? All right. So here's a business and they want to figure out what students want to use. So what's the best way to do it? And, make sure they want to minimize bias, right? So if you're trying to minimize bias, um, you probably like you don't want to limit yourself to a group of students that would have a preference. So if you're trying to minimize bias, I would say that just, make sure that you ask a high amount of random students. Like make sure that this is truly random and make sure that it's like a high amount of students. Because if it's not random, and maybe, if you're just talking to a particular group of students that likes cash, they're just gonna say, oh, I want to do cash, I want to do cash. And you're this business and you're gonna think, okay, then maybe we should just take cash. Right. So make sure you ask a high amount of random students so you can actually get like different types of answers to cover yourself. Okay, so that's 25. That was not bad. 26, determine the solution algebraically. Okay, so let's go for this. It's 26. We have to get rid of the radical. So we're gonna square both sides. So we're gonna get 3x plus 7 equals x minus 1 squared. Okay, so x minus 1 squared is x squared minus 2x plus 1. And then we have to set this equal to 0. This is going to cancel out. So we get 0 equals x squared minus 5x minus, what's that going to be? Minus 6. And then we could factor this. Fingers crossed. I hope it's factorable. So we could do -6 plus 1, right, equals 0. So we're going to get x equals 6, x equals -1. That's my answer. And yeah, of course, you could check that. And you should check it because you have a radical equation. So you might have to reject a solution. So we have, let's do the check, okay? So let's start by checking with the 6. So the square root of 3 times 6 plus 7 equals 6 minus 1. So that's 18 plus 7 is 25. Yes, this checks out. 6 is good. Now let's try with -1. So we got 3 times -1 plus 7 equals -1 minus 1. So this is going to be the square root of -3 plus 7. This is going to be the square root of 4. All right, so now the square root of 4 is 2. All right, so -2, sorry, 2 does not equal -2. So I think that's something that should be rejected. So we're gonna go ahead and reject -1. Okay, let's continue. So 27. The population of bacteria in hundreds after T hours can be modeled by the function P. Determine whether the population is increasing or decreasing over time. Explain your reasoning. So I think, the easiest approach, if you look at the graph, right? I know that my students like visuals, so I'm going to give you guys visuals. If you look at the graph, right, it's 37, and then you've got this e to the 0.0532 x, right? You look at the graph, 37e. All right, so I probably just need to zoom out. Okay, so you could see the graph is increasing. Let's zoom out some more. Right, you could see the graph is increasing. And we could talk about why that is, but what's like the best explanation that you could give? Well, there is no best, right? The best explanation here is the one that you can give, right? So what did we do? what did I do, right? That's the wrong whiteboard, sorry. I graphed it, right? And so you could say for number 27, you could say the population is increasing over time because the graph of P of T is increasing. And that would be a good explanation. And I think that we should just answer it that way and keep it simple. You can also say stuff like, you know, as the X values get larger, the Y values get larger. You know, it's just another fancy way to say, right, that the graph is increasing, right? As the X values get larger, the Y values get larger, meaning the graph is increasing. The graph is, that's spelled increasing wrong. The, okay, so okay, so the population is increasing over time because the graph of P of T is increasing. As the X values get larger, the Y values get larger, meaning the graph is increasing. That's it. Keep it simple. The polynomial function G has a factor of X minus 3. Determine the value of A. Okay, now let's think about the meaning. Let's think about what this means, right? That G has a factor of X minus 3. So one of the things, right, that we have said in my class is that the factor gives you the zero, gives you the x-intercept. So G of 3 is equal to 0, right? It's like, it basically means that if you did synthetic division on this thing or long division on this thing, you would have no remainder, right? The remainder is 0. I do hope to show synthetic or long division at some point in this video. I think it would be good for you to see it. But for now, we could use this interpretation. Like, this is telling us G of 3 equals 0. So what that means, right, is like if X equals 0, if X equals 3, excuse me, if X equals 3, right, G of 3 equals 0. Okay, it means also if X equals 3, Y equals 0. So if we substitute into this, right, we get 3 to the third power plus A times 3 to the second power minus 5 times 3 plus 6. This should equal 0. And we could solve this equation for A. So this is going to be 27 plus 9A minus 15 plus 6 equals 0. Let's clean this up. 27 minus 15 is 12, right? Yep, 12. 12 plus 6 is 18. So you get 9A plus 18 equals 0. So you get 9A equals negative 18. So we get A equals negative 2. Okay. All right. So again, like, how did I do this, right? So basically here, this is telling you like X equals 3. That's what that's telling you. X equals 3 and Y equals 0. And then I just substitute it, right? Like, this is the Y. Remember, like, G of X, that also means Y. I substituted for X and for Y, and I solve for A. Okay, that's 28. Let's keep it going. I'm gonna try to go faster this time, okay? Just because I know we've been on here a while. If you've been with me since 11, like, shout out. you know, you're a real one. You're a real one. You're the MVP. Hold on, I have to start transferring the questions to this thing. Let me just give me a second to just transfer some of these questions from the file to this. Give me a moment, all right? Just bear with me 1 second. Now, if anybody's interested in helping me edit this video for the for when it, probably gonna have to edit this because there's a lot of these moments, I guess, where nothing's really going on. It's gotta be annoying as a viewer. Sorry about that, but you're a trooper for bearing with me. Okay. All right, let's continue. So write a recursive formula for this sequence. So remember, for a recursive formula, you have to identify the first term, right? So here A1 equals 189. Okay, then we have to decide if it's adding or multiplying, like, what's going on here. So from 189 to 63, from 63 to 21, from 21 to 7. So, I see a pattern right here from the 21 to 7. It looks like it's dividing by 3, right? That's what I see, right? It's a division by 3. Each time it's dividing by 3. 189 divided by 3. Let me just check that on a calculator. 189 divided by 3. Yep, that's 63. 63 divided by 3 is 21. 21 divided by 3 is 7. So each time is dividing by 3, right? So to get the next term, right? So to get the next one, so A sub n is equal to the previous term, right? So it's equal to the previous term, A sub n minus 1 divided by 3. And that's it. That's the answer. Remember, this A sub n minus 1, that just means previous term, right? A sub n minus 1 means previous term. Okay, you don't have to write that. That's just me writing that now for you so that you know, right? So the actual answer that we get is that. Okay. So let's keep it going. All right. It says solve algebraically for x. So, all right. We have an x in the exponent. So if you're my student, I've always told you this, right? If you have an x in the exponent, that means that at some point you're gonna have to use log operations, right? There's no way, there's no ifs and buts about it. You're gonna have to use operations of logs at some point. So you could use the natural log, ln, um, because it has like a e. I would use ln, but you can also use the other log that also would work here. But I'm going to use ln. So I'm going to take the ln of both sides, the natural log of both sides. Actually, I can't do that yet. Let's undo that. I want to actually first, I want to isolate the exponent with the base. So I'm going to divide both sides by 2 first. So this is going to cancel out. So I get e to the 0.49x equals 7.5. And so now I'm going to do the natural log. So I'm going to do the ln of both sides. Sign here. Okay, so I'm doing the ln of both sides. Okay, so now having done that, that allows me to take this 0.49 and to move it to the front. So I get 0.49 ln of e equals the ln of 7.5. The ln of e is just 1, so this cancels out. There should be an x here, right? I forgot to bring the x over, right? So the ln of e cancels out. So I got 0.49x equals the ln of 7.5. Then I'm going to divide both sides by 0.49. So how do they want the answer? They want to round it to the nearest thousand. So let's do that. So the ln of 7.5 divided by 0.49. I get 4.112. That's my answer. Four 4.112. So x equals 4.112. You know, that's how you do that. Um, yeah. Let me just check something real quick on my calculator. Just want to see something. What I'm checking now is how it would have worked out if you did this with just like the regular log, like the log, not the ln. Because I have a feeling like some of my students would try this just with the regular log. And I guess should work. Log. But I just want to check and make sure it does. Just bear with me. Yep, you get the same answer. So I'm just gonna put that on the screen. Um, you know, for any student that tried it with the regular logs, it works the same way. You get the same answer, right? So if you tried it with logs, it works. You're just gonna have to also divide by the log of e. That's all. But if you see a e, you should go straight to the natural log. Just keeps it simpler because when you take the ln of e, you just get 1. Okay, let's keep going. What are we up to? 31. For all values of x, for which the expression is defined, write the expression below in simplest form. So I'm gonna have to do some factoring here. So at the numerator, we could do some factoring by grouping. Let's start with the numerator. So let's factor out a x squared. So we got a 2x plus 1. And then here we could factor out a -9. And then it's just going to be 2x plus 1. Right, so this is my numerator right now. Right now, I'm factoring my numerator. Okay. So having done that, okay, you're gonna get 2x plus 1 and then times x squared minus 9. And you could see that that x squared minus 9 can still be factored some more. So we're going to get 2x plus 1, and then x plus 3, and x minus 3. That's the numerator. All right, now on the denominator, I'm just going to write denominator here. Denominator. Okay, on the denominator, you got this 3x minus x squared. You could factor out an x, right? And then it's just going to be 3 minus x, right? X times 3 is 3x, x times negative. Yep. So that's the denominator, right? So when you put it all together in the numerator, you have 2x plus 1, x plus 3, and x minus 3. And then in the denominator, you have x and then times 3 minus x. So now what can you cancel out? Okay, well, you could cancel out like factors, and you can also cancel out this x minus 3 with this 3 minus x, as long as you just, you just multiply by -1, right? So I'll just multiply by -1 up here at the top, right? So you could do that. Okay, some of you might not remember, maybe you were absent that day, but a minus b over b minus a, like this is equal to -1, right? And that's what you have here, as long as a or b are not 0, blah, 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 right? But just, you could cancel these out as long as you just write -1 like that. Multiply the numerator by -1. So as your final answer, you're going to get the -1, right? And then the 2x plus 1 times x plus 3 over x. That's my final answer. Okay. Okay, if you have questions about that, okay, feel free to ask in the chat. And I could answer that. Let's keep going. 32. See what they want here. An app design company believes that the proportion of high school students who have purchased apps on their smartphones in the past 3 months is 0.85. App design company believes that the proportion of high school students who have purchased it is 0.85. A simulation of 500 samples of 150 students was run based on this proportion, and the results are shown below. Okay, so they gave us a mean, they gave us a standard deviation. Hopefully this is like a question we could do normal CDF on or something like that. Suppose a sample of 150 students from your high school showed that 88% of students had purchased apps on their smartphones in the past 3 months. Based on the simulation, would the results from your high school give the app design company reason to believe their assumption is incorrect? All right, so this is a confidence interval type question. All right, so let's talk about confidence interval, right? It's something that we talked about in class. It's come up, okay? It's a confidence interval type question. And so let me see if I could just pull up my note on this. Okay, so let me just show this diagram. So this is just notes, okay? You don't have to show this for the test, right? This is just a diagram I want to share with you. Okay, can you see that on the screen? I think you should be able to see that. Let me see what it looks like on the live. Just give me 1 second. Okay, just as you wait, shout out to you guys on the live. Okay, I know Halen's here, Josh, Hit. You know, if you're here and you want to let me know you're here, tell me you're here. Okay, so you could see, right? So within 95%, that's like within 2 standard deviations, that's expected. Outside of the 95%, that's something that's unusual. Okay, so let's use that knowledge here, right? So what they're asking, right? It says, suppose a sample of 150 students from your high school showed that 88% of students had purchased apps on their smartphones in the past 3 months. So what they're really asking us here, okay, what they want to know is, does the 0.88 fall within the confidence interval? Okay, that's what we're being asked. Is the 0.88 within the confidence interval? Okay, so let me just put up a formula, like a nice little handy dandy formula that you could use on this thing. Okay, so you see questions like this, what I want you to do, okay, what I want you to think about is just the mean. I want you to take the mean and I want you to add and subtract 2 standard deviations, and that's going to give you 2 numbers, right? It's going to give you a low range and a high range. So in this case, the mean was 0.852 plus the standard deviation was 0.029. Add that up for me. Tell me what you get. And then 0.852 minus 0.029. Add that up for me. Oh, actually, I forgot to multiply by 2. Don't add it up yet. Right? You have to, it's by 2 standard deviations. Right? So it's 0.852 plus 2 standard deviations, 0.852 minus 2 standard deviations. Okay, so add that 0.852 and that product, and then do 0.852 minus that product. Tell me what you get. Okay, I'll do it now here as well. Let's put it up on the calculator. 0.852 plus 2 times, what was it? 2 times 0.029. Okay. Oh, I did that wrong. I forgot the decimal. 0.852 plus 2 times 0.029. Okay, do that. Okay, and then let's do that again, but with a subtraction sign. Okay, so you get this 0.794. All right, so let me show you, and this 0.91. Let me show you what that means in the context of this problem. Okay. What that means, all right, so this was 0.794, and then this was 0.91, right? What that means, let's go back to our drawing here, right? 0.794, right, is going to be right there, and then 0.91 is going to be right there, right? So within 2 standard deviations, you have, so basically 95% of your population is within 2 standard deviations, which these numbers 0.794, right? That's minus 2 standard deviations from the mean, and then 0.91 is plus 2 standard deviations from the mean. Now, where would 88% fall? 88% is 0.88. 0.88, it would fall, like it would be here somewhere. It would fall within that range. So there's nothing unusual about it. It's expected. Like 0.88 is expected, right? This is expected. So it says, based on a simulation, would the results from your high school give the app design company reason to believe their assumption was incorrect? So what was their assumption? An app design company believes that the proportion of high school students who have purchased apps on smartphones the past 3 months is 0.85. A simulation files who run, and the results are shown below. Suppose sample showed that 88% of students had purchased apps on their smartphones. Based on simulation, with the results from your high school, give the app reason to believe their assumption is incorrect. No, right? There's nothing, they're fine, right? So what you would answer here is I would just say they're not, there's nothing incorrect. So you could write something like this. Okay, so I'll show you. So you could say, no, they are not incorrect. Incorrect. Whoops. Since 0.88 falls within the confidence interval. Okay. So they assumed fine. The assumption is fine. All right, let's keep going. Keep it moving. Page 7. All right, part 3. All right, we're making progress. We're making progress. We're getting there. I think we should be done, I want to say by 2:15, 2:30, the latest. Patricia creates a cubic polynomial function p of x with a leading coefficient of 1. The zeros of the function are 2, 3, and -6. Write an equation for p of x and then sketch p of x. Okay, so because they gave the zeros, okay, we know that this function has to have like the factors of x minus 2, x minus 3, x plus 6, right? It has to have like these factors, right? Those zeros give you these factors, right? And from these factors, you could write p of x. You just have to put the leading coefficient in the front, and it says the leading coefficient is 1, so it's going to be 1, and then times the factors. Okay, so that's the first part. That's p of x. Then they want you to sketch the function. So we know already, right, that it's going to have a 0 of 2, right? So that's 1, 2, a 0 of 3. Okay, and then 1, 2, 3, 4, 5, 6, and then a 0 of -6, right? So we're going to have a 0 here, a 0 here, and a 0 here. Okay. Now, this is going to be, right? This is going to be a function that is going to have an odd exponent. Like the highest exponent is going to be an odd number, which in this case is going to be 3, right? This is going to be a x to the third. You see, because it's x times x times x, right? So the function, the end behavior has to have opposite end behavior. You see, opposite end behavior. So that means that our function, because it has a positive leading coefficient of 1, our function has to look like that, right? It has to do that. Okay, so I'm gonna do this. And then I think you should be able to get away with that. If they just want a rough sketch, it doesn't, they're not asking for like, because, you could think about what's the y-intercept here. And I mean, you could find it. You could find the y-intercept. You could say let x equals 0. And then you could find it that way. But I think this rough sketch is fine since I didn't label anything for the y-axis. So We're good. Keep it moving. 33. 34. Public radio station held a fundraiser. The table below summarizes the donor category. To the nearest thousand, find the probability that a randomly selected donor was categorized as a supporter, given that the donation was made online. All right, so we need totals for this table because we were not given totals. Okay, so let me extend that table. Right, so if you add the total phone calls, that's 400 plus 672, that's going to be 1072. And if you add the total of online, that's 1200 plus 2016. So is that 3216? Yep. And then we're gonna need total for supporter and patrons here as well. Okay, so the total supporters is 400 plus 1200. That's going to be 1600. Total patrons is going to be 2688. Okay. And then the total amount of like everything, which I don't think we need that right now. So since I don't need it now, I'm not gonna find like the total of everything, but so to the nearest thousand, find the probability that a randomly selected donor was categorized as a supporter, given that the donation was made online. So since the donation was made online, all right, let's highlight what we should be focusing on. Okay, because the donation was made online, I should only be focusing on this row. Right, given the donation is online, so just focus on the row that says online. Don't focus on anything else. How many supporters given that it's online? Well, it's 1200 out of 3216, right? That was the total of online. That's my answer. Okay. And do they want us to round this? Yes, it says to the nearest thousand. So let's go ahead and divide that. Get your calculator. So it's 1200. I'm just going to do it real quick here over 3216. So I get 0.373. Okay, I'll show you what I did. 0.373. Right. 0.373, right? You got to round to the nearest thousand, so you had to divide it. Do these data indicate that being a supporter is independent of donating online? Well, we have to now think about what's the probability of donating online, right? Like, what's the probability that being a supporter? So, do these data indicate that being a supporter is independent of donating online? Well, let's see. All right, I'll show you how. So, in total, like when you add up all the people, right? When you add up the totals here, you're gonna get 3,288, right? 3,288. Yep. Okay. Now let's think about it. how many supporters, like what's the probability that you're a supporter in this whole experiment? This whole experiment, the probability that you're a supporter is 1,600 out of 3,288. What is that roughly? Let's get our calculator. 1,600 out of 3,288. You get 0.487 about, right? 0.487. I think I added something wrong. Somebody's alerting me to the fact that I added something wrong. Thanks for letting me know. Someone's telling me my total here was wrong. I gotta fix that total. It's actually 4,288. 4,288. All right, so let's do that again. So 1,600 out of 4,288. So this is gonna roughly equal 0.373. Okay, so now let's go back to the question. Do these data indicate that being a supporter is independent of donating online? Okay, so let me pull up my notes on this thing. Just want to make sure I say this right. Give me 1 second. Just bear with me. Okay, so sometimes, with these probability questions, it's a little more nuance to it. Okay, so we're checking to see if like the events are independent. So I just want to put up some notes for this. Okay, so let me just put it up. All right, so these are notes for you. This isn't part of like the solution. Okay, these are notes. Okay, so two or more events that are not related and do not affect each other. Okay, so if A and B are independent events, then the probability of both occurring is the probability of A and B equals the probability of A times B. So I just did the left side of this equation. I just did the left side of this thing. Okay, and then this is just the same thing as that. I just did the left side, right? So what I did is it says, do these data indicate that being a supporter is independent of donating online? So I just went and I found, well, how many supporters out of the whole total? So that's how I got. So supporters is a total of 1,600 out of the total experiment is 4,288. So, but now what I have to do is the probability of being a supporter, right? So the probability of being a supporter, and I have to multiply that by the probability of donating online. Okay, so the probability of being a supporter, that's 1,600 out of 4,288. And I have to multiply that by the probability of donating online. So the probability of donating online is so Give me 1 second. Let me check my notes on this. Doot, 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 doot. Mm, 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 mm. Okay, so the probability of the online is 3216. Okay, 3216, and then out of the whole thing, right? 4288. Okay, so now let's check that. So 1600. Okay, so 1600 out of 4288. Okay, and I know we just did that before, right? Times, what did I say? 3216, right? 3216 out of 42. So you get this number, 0.279. All right, so let's bring it back. Okay, so you get this number, 0.279. Okay, so that's what this equals. Okay, so now having done that, I got the probability of A times the probability of B. So I think what I did before this part here, you're gonna hate me for this. I don't think this was the way I wanted to go with that. All right, so just ignore that. Cross that out, okay? Cross that part out. Just forget about that part. All right, we found the probability of A times the probability of B. So do these data indicate that being a supporter is independent of donating online, right? So what we did is the probability of A, okay, that's the probability of being a supporter. And then the probability of B, that's the probability of donating online. Okay, so and we got this part. So I'm gonna tell you what I was trying to do there before, but that I didn't do correct, right? So now we have to do this part here, right? The probability of A and B. But we have to do it just from the table, just like looking at that table. So that's gonna be, and let me just say this in a way that makes sense to me the most, and also is gonna make sense to you. Okay, so do these data indicate that being a supporter is independent of donating online? So that basically means, right? What's the probability that you are that given that it's an online donation, you're a supporter? What's the probability that given that, no, that's not how I want to say it. Um, So the idea here, right, is if you look at online supporters, right? Think, okay, so now I know how to say it. How many online supporters do you have? 1,200. There's 1,200 online supporters out of 4,288. Okay, I'm sorry it took so long, but this is right, right? There's 1,200 online supporters out of 4,288. Is this amount equal to 0.279? Let's see. So 1,200 out of 4,288. All right, let's show it on the calculator. It's the same thing, right? So you could see here, right, from the calculator, the probability of A times the probability of B, you get 0.279. And then just from the table, right? So just from the table, it's like how many online supporters do you have, right? You have 1,200 out of 4,288. Okay, so since both those things are equal, that would mean that yes, this data indicates that being a supporter is independent of donating online. All right, let's keep going. All right. Okay, algebraically solve the system of equations. All right, so we have like a circle and then we have a line. But even if you didn't know that, you're given a y value, right? You're given this y value of negative 2x plus 7. You can just substitute that in there. So we're going to have x minus 2 squared plus, and then in here you have negative 2x plus 7 minus 3 to the second power equals 20, right? So now we just have an equation with one variable, which is nice. All right, so let's clean it up here on the inside. So you got x minus 2 squared plus negative 2x plus 4 squared equals 20. Okay, so we're gonna have to do distributive, like we're gonna FOIL this out. So this is gonna equal x squared minus 4x plus 4. That's what this one's gonna equal, okay? And then this one here, negative 2x plus 4, negative 2x plus 4. That's going to be 4x squared. And then it's going to be negative 8x and then negative 8x and then plus 16, right? So this is going to be plus 4x squared minus 16x plus 16 equals 20. Okay, so you got the x squared plus 4x squared, 5x squared. You got negative 4x minus 16x, negative 20x. Then you have this 4 plus 16. That's plus 20 equals 20. So then these 20s, right, they cancel out because you're going to do minus 20 minus 20, right? So they're just going to cancel out. So you got 5x squared equals 20x. No, I shouldn't do that. 5x squared minus 20x equals 0. Factor out of 5x. So we get x minus 4 equals 0. break it. So you're gonna get x equals 0 here, and you're gonna get x equals 4 here. All right, so you x, now you just gotta find y. So y equals -2 times 0 plus 7. So y equals 7, right? Like when x equals 0, right? So you got 0, 7 for one solution. And then when x equals 4, it's going to be y equals -2 times 4 plus 7, y equals -1. So we got 4 comma -1. Those are my answers. Okay. 0, 7 and 4 comma -1 confirmed. All right, let's keep it going. I think I have to add more of the problems. So that was 35. Are we up to the last one? Is 36 the last one? It, I think 36 is the last one, guys. If you stayed all the way onto this, if you stayed all the way till the end on this, man, um, I'm gonna have to give you some extra credit. I mean, because those were some hard problems that you stayed on for. You know, some of those were kind of annoying too. Actually, 36 is not the last problem. There is one more, 37. Sorry if I got your hopes up. All right. So what are we up to here? 36. On a certain tropical island, there are currently 500 palm trees, 200 flamingos. Suppose the palm tree population is decreasing at an annual rate of 3% per year, and the flamingo population is growing at a continuous rate of 2% per year. Write two functions, p of x and f of x, that represent the number of palm trees and flamingos on this island, respectively, x years from now. So p of x, start with that. Okay, so p of x is for palm trees. Okay, so it says it starts with 500 palm trees. So start with that. And it's decreasing, so it's going to be 1 minus 0.03, okay? Because that's the rate, and you have to subtract it from 1. And then that's just going to be raised to the x. And then the flamingo population is also exponential, right? So it starts with 200 flamingos, and the flamingo population is growing at a continuous rate. So that means it's an e to the RT. So e to the 0.02x. Okay, so there's a sheet I gave you guys with all these formulas. If you need that sheet, hit me up in Google Classroom, and I'll let you have it again. If you're watching this video and you want that sheet, leave me a comment and I'll put it up. I'll figure out a way to like pin it or something, put a link up. All right, but those are the equations I get. I got p of x and f of x. That wasn't so bad. There's another part, right? State the solution. They just want us to set these equal to each other. Interpret the meaning of the value. All right, so the way that we're going to solve this, we're going to use our graphing calculator. So we're going to go to y equals, we're going to graph both equations, and we're going to see where they intersect. So the first one was 500, and then it was 1 minus 0.03 to the x. And then the second one was 200 e to the 0.02x. And then we just want to see where they intersect. Let's try zoom 6. It's just a zoom standard. That's worse. Okay, let's try to zoom out from there. Let's keep zooming out until we get something. Let's keep zooming out. There you go. So that's where they intersect. So let's do a second trace intersect. And then you could just go to the close to the point and press enter 3 times. So they intersect at x equals 0.425. Okay, so they intersect at x equals 0.425. Sorry, I got x equals 29.425. But you know what? That graph, that second graph looks wrong. It looks like a straight line, and I'm expecting an exponential. And I did do something wrong. I forgot to put the x next to that. So I'm sorry, we got to do that again. See, I knew they were supposed to look exponential, so I was like, something's not right here. 1, 2, 3. Okay, so x equals 18.159. So that's the solution. And they want it to the nearest year, so we're just gonna say 18 years. So let's go back. So the solution is x equals 18 years. And now what does it mean? So what it means is at year 18, the population, you could say at about year 18, at about, because it wasn't exact, right? At about year 18, the population of flamingos and, what was it, palm trees will be about the same. Okay, now we are really up to the last one. And it looks like it might be like a simple sinusoidal function type thing. So the volume of air in an average lung during breathing can be modeled by the graph below. Using the graph, write an equation in the form. Okay, so this is nice. I like this. So this doesn't look so bad so far, right? So C is the midline. Okay, A is the amplitude. A is the amplitude. Okay, and then B. Okay, so do you remember the way I taught this to you, right? I told you the period, right, is equal to 2 pi over B, right? So B is the frequency. But I think we're gonna have to calculate. We're gonna have to calculate the period. We're gonna have to calculate the frequency from the graph, but we'll worry about that later. So first, let's identify the midline. Okay, so they made it. This is not so bad, guys. They put these dots on it, which kind of makes things easier. So that's the midline right there. It looks like, if I look at the graph, it's going by 2, 4, 6, 8. It's going by 200s. So I think this is going to be 2400. So the midline is 2400. Okay, now the amplitude is this distance here, right? So it looks like the amplitude is 400. Right, so if you write that, you're already getting points on the test, right? So this is the amplitude right here, right? This part here, that's the amplitude. The distance from the midline to the max. or the distance from the midline to the min, right? So that's 400, right? Amplitude is 400. Okay, now we got to calculate that B. Okay, so the period is the horizontal length of one cycle. So the period, right? So here's one cycle. It goes from 0 to 5. Oh, they made that so nice. So the period is 5. So you get 5 equals 2 pi over b. All you got to do is solve for b. You could put this over 1, cross multiply. You get 2 pi equals 5b. Divide both sides by 5. This cancels. B equals 2 pi over 5. So the answer is n of t equals 400 sine of 2 pi over 5 t, and then plus the midline, which was 2400. Okay, that's the answer to that one. $400, the sine of 2 pi 5t plus 2400. Okay, nice. I think there's more to this. That's too easy to be a number 37. There's another page, right? All right. So let's see. On the same lung, I mean, at least it's an interesting problem. On the same lung, when engaged in exercise, that same lung, when engaged in exercise has a volume that can be modeled by E of t, where E of t is volume in milliliters and t is time in seconds. Graph at least one cycle on the same grid. Okay, so let's go back to that. And then I'm going to, maybe I could just copy this so I don't have to keep going back and forth. Because you know I'm going to forget. You know I got that horrible memory. Guys, thanks for staying on this long. Jeez, I can't believe you guys stayed on this long. I can't believe it. And now this thing's lagging. Don't lag on me, bro. Okay, so let's paste that there. Okay, so we got to graph this guy, right? So the midline is 3,200. So I'm gonna use blue for this, right? So it'll just make it easier, right? So the midline is 3,200. So the midline has to be here. All right, it's got to be about there. Let me just erase this since I don't need that anymore. Erase. Is there any eraser on this thing? There is. Okay. Okay, erase, erase, erase. Okay, so there's my midline. It says the amplitude is 2000. So that means from the midline, I gotta go up 2000. So so if it's the midline's 3,200, I gotta go up to 4,200. Okay, so that's gonna go up to there. That's gonna be the max. Okay, and then 3,200 take away 2000, that's 1,200. No, I said that wrong. 3,200 take away 2000. Okay, I think I did my max wrong, right? It's supposed to be up here. 5,200. Okay, that's the max. Right, so the max is 3,200 plus 2,000, and then the min is gonna be at gonna be down there at 1200. All right. So that's that. The So it's a sine function. Okay, so you know that it has to start at the midline. Yes, it does. Sorry, I wasn't sure for 1 second. So it has to start at the midline, the sine function, right? The y-intercept has to be at the midline. Let's figure out the period for this one. So the period is equal to 2 pi over b, which b is pi. So these pi's cancel. So the period is 2. Right? So what that tells you is that one cycle should end here at 2, right? So one cycle should go from 0 to 2. So I'm just going to make a line so that it's clear to everybody that's watching, right? Like I want to make sure I end my cycle there. Right? So okay, so from here to here, it has to be one cycle. That means I have to have like those 5 key points from here to here. So I'm going to break this in half. So that's going to be right there. And then I'm going to have a max here, like right halfway between this and that. And then I'm going to have my min here. And so it's going to look like, oh man, that's not so bad, man. What? That's not so bad. That looks all right, actually. So that's my graph. And then it says how many times during the 5-second interval will N of t intersect with E of t? I was reading the last question. I guess you know what I should do is I should graph, like I should keep graphing. So let's keep going. Boom, 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 boom. Okay, like that. And then it's gonna go back up to there. Right. So it's like every 2 boxes you draw a key point. Boom, boom. Okay. So how many times do our graphs intersect? So you could see they intersect here. Whoop, let me use a different color. Here, 1, 2, 3, 4. Guys, we made it. Guys, you made it all the way to the end. You really did. That's crazy. That's so crazy. Right. So before I just start singing victory, let me just write the final answer. All right. Hold on. Stop doing that. 4 times. How many times during the 5-second interval will N of t equal N of t, right? This is just asking for intersections. 4 times. All right. Wow. We've been on since 11. It's now about 2:30. So you've been on here a while. 4 people are still watching. Jesus. 4 people are still watching. Thank you to those 4 people. Sarabi, it's algebra 2, girl. Or boy, or them. Sorry, I didn't want to assume pronouns. I know. Anyways. But for real, Freddie, I see you. Shout out to Freddie if you're still on this thing. Shout out to Hit. Shout out to Halen. I can't believe we stayed on. I'm gonna be at the school at 8 in the morning on Monday. Okay, I'll be there at 8 and I'll be doing prep. I'll probably just be covering the equivalent stuff. And I think some sinusoidal stuff, the statistics stuff. And man, love you guys like for staying on, even though it's just 4 of you. But you know what? I'd rather have 4 faithful people. I'd rather be followed by 4 faithful people than to have a crowd of like superficial followers. All right. I'll take the 4 real ones. All right. Peace. Later, guys. Have a good one.